And welcome to Build to Hack and Hack to Build. So, who am I? My name is Chris Leroy. I am a platform security engineer at Heroku. So, I pen test the platform. I research a lot of things, mostly things that distract me. There's a bit of echo. And then, of course, work quite closely with our engineers and actually get to engineer some pretty cool solutions. So you can find me on the cybers at Brompony. And a theme that you might pick up in this talk is that I like building stuff, and I like hacking stuff, and I've built quite a few things for hacking on the web, Windows, Android, and more recently, containers. So what am I going to share with you today? So a bit of a problem that I encountered quite recently. We'll look over some existing research. I'll introduce BOtB with a silent T, and I'll show you some things that you can do with BOtB, and of course, a conclusion. So what are the problems? And you'll see those 2 points at the bottom are two questions that I ask myself quite a lot in our relatively modern cloud DevOps SDLC agile environment. And when I put my pen tester hat on, I'm often asking myself, how do I identify and exploit vulnerabilities? The points under that is same but different question. If I put on my engineering hat, I ask myself, how do we test, secure, and monitor our containers? So there's a lot of similarity between those questions, but the actual manifestation on how you're actually going about answering those questions can differ quite significantly. So in terms of those fields and containers, what exists out there if you're looking at pwning containers or looking for vulnerabilities? First things first, when you're on a container, am I contained? It's going to tell you if you're in a container, which if you're going to try and hack, it's good to know. Then there's a great set of tools from Google, so Google Container Tools. So in terms of static analysis, there's a lot of interesting stuff. There's, of course, some tools from Claire, so vulnerabilities. So run it on your images and tell you, hey, there's this CV on this package, so on and so forth. And then, of course, there's your family of benchmarking tools. So from Aqua Security, there's the Docker benchmark. So you'll see there's a lot more tools out there. I've just mentioned a few tools that cover the broad categories of container tools that you can find out there. And how do I like to solve problems? Because there weren't a list of tools there that helped me solve my problems. And my general approach to things in life is, let's just pwn it and break it. So that's what I did. I created something called Break Out the Box to help me exploit container vulnerabilities and verify exploitability. I had a bit of an issue with a lot of scanners saying, you're vulnerable to this. And as Tash was saying now, show the POCs. There's a great saying about, have POCs or, exit the room. So I wrote something that'll help me do that. So just a brief outline written in Go. So something that all the cool kids are coding in these days, but I hear that's moved to Rust now, so I might have to fork it and move it to Rust. But I'm quite lazy when it comes to hacking. I don't like to repeat the same thing over and over. So it's got the ability to auto-pwn common container vulnerabilities. So the skids will be very happy about that. It also allows you to do some common post-exploitation things in containers. If you're familiar with post-exploitation or living off the land, there's a lot of tools and procedures that you do over and over. So let's automate that. And then the last point there, which is a big focus point for me, was that, well, let's not just make this another hacker tool that is not very friendly towards anyone who's not running Kali Linux every day, but let's make it useful for pen testers and engineers. Because, if you're not using your own tool and if it's not easy for other people to use, engineers probably aren't going to use it. So first things first, when you're hacking containers, the hollow world of hacking containers, and especially Docker containers, is docker.soc, so the 101 method. It often stems from having to use Docker within Docker, which is just generally a bad idea. TLDR, this allows you to basically break out of containers and perform a local priv-esc of sorts to root on the underlying host. That's a lot of fun. So how do you do it? Step one, you got to find the socket. Step two, you got to interact with the socket, so you can use the Docker client or curl or socket or whatever you want that can speak to Unix domain sockets. You then want to create a new container and mount the host's namespaces, so whether it's the PID namespace or network namespace, mount it as privileged. And then when you run that, you want to chroot, then basically the container that you are in is basically root on the host, and then that's where you can go ahead and cause havoc. So that's pretty much the recipe that you do. There's a ton of resources online how to do that. And I got a bit annoyed that when looking for this kind of attack on a lot of hosts, things can get tricky. So a lot of Unix sockets aren't necessarily going to be named docker.sock. It could be called moo.sock or something else like that. So how do you go ahead and actually find these things? A lot of containers or images like Alpine might not have the find command. So a lot of living off the land can get tricky when the commands that you need to perform your post-exploitation don't exist. So find, ss, netstat, so on and so forth. So, like I said, as well, sockets might be mounted as something else. It might not be as obvious as var run docker.sock. Might be /move/bob. How do you find these if you don't have the find command or other commands to help you there? So, syscalls are your friends. Just because the commands aren't available in the container doesn't mean that the syscalls don't exist. So, to the left are the syscalls that are implemented for the find command. Just use strace to find that. And then on the right is actually just some Go code that I actually wrote to actually implement the find command to do that. So I figured, okay, cool, well, if there's no find command, then I can just slap together some Go code and get a binary, and then I have the find command. So how does this actually look? So what we're going to do with Bob is we're going to go ahead and break out of a container. So at the top, we basically have the underlying host. And then at the top terminal, we're going to now run into a Docker container. So standard Ubuntu, Docker run. And we've mounted our socket. So we've mounted it as /temp. This is not a socket. And then what we're going to do is we're going to tell Bob, OK, first go ahead and tell me what you can do. There's a lot more functionality now. This video is a little bit old. But we're going to tell Bob, look for all the sockets, all the Unix domain sockets. And Bob's gone ahead and said, oh, cool, we found this Unix domain socket. What now? So we're going to go ahead and tell Bob, just auto-pwn, like just bring all the shells. That's what I want to do. So Bob's going to go ahead, it's going to scan. It's going to identify these sockets. It's going to see if it can actually pwn it. And there we go. We're now actually in a container, in a TTY on the underlying host. And if you'll see that from that ls, that's actually a OSX host over there. So now I'm root on the underlying host, which is the result of mounting my Docker socket within my container. And I'm not going to create a file, and that will appear at the bottom terminal, because the bottom terminal is a terminal on my Ubuntu host. So I said earlier OSX host wasn't OSX, it's an Ubuntu host. And then if you exit Bob, you exit your TTY, you then actually go back to your container. So it's quite fun. And you see there's the socket. So when it comes to hacking domain sockets or identifying sockets, it can get quite useful. But that's very much got your pen tester approach on it. Now, I want to get a shell. And of course, that can be useful if you find yourself on a host and you want to get a TTY and get a shell. But for an engineering environment, this might not necessarily be very useful, especially in CI/CD environments. And I'll get into that in a bit. But we can also use return codes. So don't drop to a TTY, but send a return code greater than 0. Because what do we know about CI environments? Return codes greater than 0 indicate a failure. So I'll show you that in a bit. And often people ask me, so why put this binary on your container? Well, what's quite nice is that when it's compiled, it's a single binary. You don't need to download any other binaries. It's just one binary to pwn them all. So let's do this with CI. So at Heroku, we have a lot of containers and a lot of stuff going on. So basically over here, we have a CI environment. And I want to test in our CI environment, are there actually any exploitable domain sockets on our platform? Now, I'm not going to trigger a build every single time. Basically, what I've done here is in our staging environment is I have tests that automatically run that go ahead and trigger build, and it runs Bob. But you'll see that I've added the auto-pwn flag, but also I've added the -CI/CD flag. What that means is that Bob now, in this case, it's busy running a build. It's not going to drop to a TTY. If Bob successfully manages to exploit a domain socket in the environment that it's found itself in, it'll just set a return code greater than 1. And in this case, it found some sockets, but they weren't exploitable. So this build will succeed. And this is one of the things that we're doing to test our CI environments that we offer for people to use as a CI environment. And it's very easy for small vulnerabilities to slip into systems. So this is one way that we're using it. We're literally using our system to hack our system to verify stuff. And it wouldn't make sense in this case to drop down to a TTY if I'm running builds. I don't need a TTY. I don't need a shell. I just need something to tell me this is vulnerable and exploitable. So that was with my engineering hat on. How can we use that? So BOtB does it with all its functionality. It has, give me all the shells, or do it in the CI/CD environment where return codes are pretty useful. But there's more to hacking containers than Docker sockets. There's also this wonderful thing called privileged containers. Now, I had a conversation with one of our engineers, and I said, we really should not be using privileged containers in conversation. And someone said, why? I said, because it's bad. And I realized, well, the tribal knowledge that I knew about privileged containers wasn't necessarily the same knowledge that the engineer that I was speaking to. So I said, let me show you. So just things about privileged containers, all the syscalls and capabilities go out the window. Basically, it gets quite dangerous, and it's one of the easiest ways to escape out of containers. But it's also not the easiest to test for. You're in a container, how do you know if it's privileged? So of course, I went and I extended BOtB, and I said, let's just build something that if the container is privileged, try and actually break out of the container. So you'll see in the top terminal there, I'm running a Docker container with -- privileged, standard. So I always run BOtB first to see that it's running. And then basically, I just say pwn C groups. So privileged containers go weird with C groups. And basically, from that command there, I've now executed a command on the underlying host because the privileged container allows me to do that. So you saw the result there was Docker desktop. If I look at the hostname in the bottom terminal, that would actually be Docker desktop. But let's actually go ahead and get a shell. So because the container in the top is privileged, I can do some magic with agent release commands and C groups. Read up on it if they interest you. Trail of Bits did a really good write-up on this. So now I'm going to tell BOtB, break out of this container, but execute this command on the underlying host. And of course, good old netcat has to show up with a terminal with green text. Always start your reverse handler. It's always an important step. And you can see at the bottom, I just got a connection, and now I've broken out of the container and gotten root on the underlying host because it's a privileged container. So you can see a whole bunch of interesting stuff in terms of these exploits. So of course, with BOtB, you can do the same with CI/CD, so you can run this in your CI environment, or whatever environment that you want to test, where return codes can be used to determine exploitability. There's also environment variables. This can get a little bit tricky in containers, but it's pretty much good old Linux post-exploitation, nothing new here. But when it comes to containers, procfs is your friend. And the reason why I say this is that in a lot of orchestrated environments, just because the env for your process has been cleared doesn't necessarily mean that the environment variables have been cleared in procfs. So I found myself having to check env and then do some grep and awk and sed magic for procfs, which has resulted in me losing a lot more hair than I'd like to admit. So, of course, what do we do about that? Well, we automate this and we build this. And basically, you can tell BOtB, go ahead, access env for your process that BOtB is running in, and go ahead and analyze procfs. Because there's a lot of check your time of use edge cases. You've got to be really quick to analyze procfs because the process might die. But of course, this can get a little bit irritating because there's ephemerality with analyzing procfs. That entry might not exist anymore, so that's where the speed comes in. So BOtB does it really quick by going through the whole procfs tree. And then, of course, it's just general Linux procfs, which is, it's a can of worms for me most of the times. So how do you actually want to do that if you want to do it programmatically in Go? I did have a side screenshot of a bash script that did it. This looked much more cooler with all the different indentations, so I figured I wouldn't make your eyes bleed with that. So it's relatively easy to do programmatically. What does this look like in an environment? So what we'll see over here is we're going to run a Docker container. We're going to inject an environment variable called touch of approval with a value of super secret password. We're then going to tell Bob, so Bob by default, if you don't specify a word list, it'll look for the keywords secret and password automatically. So you see Bob has gone ahead and scanned and found multiple procfs entries with the value super secret password, and Bob will then actually go ahead and show you what is the full procfs path for that, which can be useful. And of course at the bottom it showed you the actual tuple for that env entry. And of course the word list can be added. So in this case I'm going to add more entries. So don't just look for secret and password, go look for other stuff. So in this case, in this word list, I've looked for YOLO, secret, find me, and it hasn't found any of those other entries. But it's quite a nice way to go ahead and verify that there are no maybe secrets or entries that aren't making their way inside containers' environment variables. So I'm going to skip that, but that bit's a bit boring. So in terms of a CI environment, so I run this quite regularly. So I have builds that just constantly run. And I know that if a particular build fails, it means that either an environment variable with a particular value was found inside the CI environment. And this is quite easy to do because it's a single binary. You just drop it on the host, you add a word list, add it to a Git repo, and then whatever environment you're running in, it'll just go ahead and run that. So I'll go ahead and I'll trigger a build. And because the values that I've specified, secret, password, YOLO, do not look RSA, the build will pass, which then tells me that it's not really building anything, but it's telling me that in our container environments, there's no environment variables or procfs entries that contain those keywords, which makes me sleep a little bit better at night. So I'm talking about containers, I'm talking about clouds, not the ones that we see in London 99% of the time. But there's these wonderful things called metadata services. And good old 169.254, 169.254, they are everywhere. They can be abused quite nicely. It is platform specific, so whether you're on Azure or GCP or AWS, you can do a lot of different stuff. That curl command there at the bottom on AWS will give you the IAM roles to a specific IAM user. If you have access to the metadata service, there's a whole bunch of stuff. So when you're in an environment and you want to find this, but maybe, curl is not installed in the box or no wget, and you're on a read-only file system maybe, and you can't apt install or APK add, you can use BOB to do that. But of course, metadata services aren't the only HTTP endpoints that you might want to test for. You might want to look for control planes. So, find a particular host name or check, okay, I'm in this container, is there egress to google.com? A great example is on EC2 Classic. If you're running an instance on EC2 Classic, that's one big flat network. And on that 10 range, if you run anything on that interface, everyone has access to that. So sometimes it's a great way to test, well, is this 10 range accessible from my container? So yeah, often you want to test, can I establish an HTTP request to a particular host? So what does that look like? So we're going to run Bob again inside a container. Bob by default, once again, if you don't specify a word list, Bob by default will look for the 169.254 endpoints. So it's looking for a whole bunch of stuff. I have also added some new functionality to this. So see, Bob also looks for Kubernetes. I'm going to add now Heroku.com. So tell me if this environment that I'm in can actually establish an HTTP request. There's also a really neat trick on GCP legacy metadata services. So if those of you familiar with metadata services, it's quite a lot to query, and you can't recursively pull down all the data. If you just establish a socket connection and a HTTP 1.0 connection and exclude the host header, the legacy service will actually just spit out everything that's under that metadata service. So I've built that into Bob as well. So if you run Bob now on the metadata pwn, if it can scrape all that data, it will go ahead and just give it to you. Instead of you having to spin up netcat and get a whole bunch of information. So yeah, Bob does that. It gives you all the information, also in CI/CD mode. So because in this demo it found it could establish a connection to Heroku.com, the return code is then 1, just to let us know that that could happen. So that's much of the recon stuff, which is very fun, but there's always a but. There's a lot of things that you can do in container environments. And binary hijacking or component hijacking is one of them. For example, when you run Docker exec on a particular container, there's no integrity checking that the binary that you're going to run in that container actually is the binary in that container. So if you run Docker exec container ID ls or bash, how do you know you're actually running the actual ID ls or bash command? Great example of that is with kube control copy. That executes the tar binary in the pod/container that you want to copy from. Twistlog did a great write-up on this, and there was a CV that came out of it. Because there's no integrity checking on the tar binary, you could hijack the binary and alter the output through symlinks and basically introduce some pretty cool pwnage. So something important to note, especially with containers, is that at some point in your container's execution, a binary might be executed either through kube control copy or through a Docker exec or previously through a Docker copy. You don't know. So from an attacker's perspective, this actually is a very interesting attack surface. So what's my natural reaction? Let's just hijack all the binaries and let's just see what happens. So just be careful. This definitely has the potential to break stuff. So don't do it in production environments or environments that you don't have mandate to, because things get a bit weird when certain orchestrators assume that they're going to receive certain output or response codes from commands executed. So how would you do this manually? So step one, you got to have read-write permissions to bin or sbin or user bin. So you got to check that. If you don't have that, you're going to struggle to achieve your goal. You want to create malicious executable. So I say executable, but it could be a script. It could be whatever that does something. I actually use webhooks quite a lot because exploitability, I might not get execution now. Maybe when the container is backed up tomorrow, do I get a webhook call? So webhooks are my favorite for this. Or of course, you could just fuzz. If kube control executes the tar command and it's not expecting 1 megabytes of AAAAA, things get interesting. Then what you want to do is then replace everything in bin or sbin or user bin with your malicious binary. So replace tar with your version of tar and do that all through the file system. Give it executable and read permissions. And then you wait and see. So in terms of the demo that I want to show you here, a common payload that BOtB uses by default is that it will hijack the command, establish what command was executed, and what were the parameters sent to that, which gets pretty useful. That's from a bash script that I used originally. You can see some of the fuzzing output. If you want to do this in bash, this is what it might look like. You don't want to hijack all the binaries because while you're doing the hijacking, there's commands that you need to do. And if you hijack those commands, you might land up in a bit of a recursive loop with no end function. So that's how it might look like if you decide to do it in bash. Some important commands there. So before we execute this kind of attack, what is interesting? Well, you might receive callbacks in 1 minute time, or 10 minutes, or 1 hour, or next week. You might get tokens and curl commands. Let me give you an example. It might be the case that maybe containers are running in some environment, and that environment that is offering that container wants to make a backup of that container or the contents of it and put it in an S3 bucket. Now, if you wanted to do that in a container, you would have to execute a command in that container to package the contents and ship it off. Now, if you go ahead and hijack the curl command, and an orchestrator says, hey, run this curl command to put that tar or that file on an S3 bucket, but of course we know public S3 buckets are bad, so we need credentials. So of course we need to provide the tokens to the curl command, but we've hijacked the curl command, so what do we get in our webhook? We get the tokens that the orchestrators are running in our container to back up our containers, because we want backups. So that's the kind of stuff that you could see. Break stuff is definitely one of them, so certain logic. So if you're running certain commands in containers and you're expecting, okay, I'm either going to get a 200 or 400 in an HTTP scenario, what happens if AAAAA is returned? How does the system respond? A few things have broken because of this, and it's an interesting way to test. So let's show you what that looks like. So on the left, where we are now in the middle split, I'm going to run a BOB command, and basically I'm telling Bob, hijack all the binaries in the container and execute the kill command, which goes to a webhook. So on the left there, you'll see that's just my logs coming from my endpoint, and it means that a command was executed. So I'm running the ID command in my container, and I'm getting a canary request saying someone's run hello YAL inside this container. Now, on the other split terminal, I'm now going to run a Docker exec command, because maybe I want to administer something in this container. So I'm going to run Docker exec ID, and then you'll see the webhook comes through on the other side. So the container is functioning. It's giving legit return codes. From the Docker exec command, it looks like it's actually happening. Everything's working, but I'm actually hijacking it and getting those parameters through. So once again, you can do that with Bob to actually get webhooks, or you can use return codes. So you can add it in your systems and have it run on certain things. And yeah, it would be surprising what actually comes through. But yes, there's always more. All those CVE things. So there's quite a few in Docker, Docker Shocker, some of the older stuff, some of the more Linux applicable ones like Bashbug or Shellshock or Dirty Cow. Those things often make an appearance. But most recently, one of my most favorite ones is CVE 2019-5736, which is the runcie vulnerability. And with these, you're on a container, now you want to exploit them. How do you go about doing that? So, similar to hijacking binaries, but in this case, you're actually not hijacking binaries in the container. You're hijacking the runcie binary on the host. Now, the runcie binary is quite important. It runs as root, and it actually runs your containers. So there's definitely a great saying, when something hits the fan, that's when the CVE happens over here. So yeah, it's pretty interesting. And the underlying issue is how runcie spawns new processes in containers. If you like the underlying mechanics of containers, I highly recommend reading up on this CVE. It's super interesting. So yeah, it is a last resort exploit. You can potentially break the underlying container runtime. So if you do this, for example, maybe in a node, you might affect all other pods, particularly in the Kubernetes cluster or maybe in a Docker swarm. But it's the runtime. You take over the runtime. To implement it, though, there are some prerequisites. So in Docker, you need to be root. And then for LXC, you need to be root and privileged. To note there, Docker and LXC define privileged containers very differently. So just be aware of that. So yeah, you basically get root privileges on the host. And what does that all mean? Where's the POC? I'll show you in a bit. It's probably the next slide. But what we're going to do in this case is we're going to use it to basically execute a webhook on our underlying host. The reason for that is that this vulnerability is triggered when an external entity executes a command within the container. So if you run this exploit, and to trigger the vulnerability, someone has to execute a Docker exec or run some other external command inside your container. So that's why I use webhooks to execute, not shells, because it might be 1 hour or 1 week until someone actually executes a command inside that container. So that's why I'm using webhooks for this. So what does it actually look like? So on the right, I'm running a vulnerable version of Docker. I think I was using late version of 17. But once again, I'm in a container. I'm going to run BOB. And yeah, the command for this one, I think I've renamed it quite recently. It's now pwn something. But yes, aggressive pwn. At this case, I just called it the aggressive hack because it was quite aggressive. But you'll see now when it runs now, the container's basically waiting for it to be triggered. At the bottom, I'm on my host, and I'm going to run Docker exec in that container. And I'm just going to run the bash command. So I'm going to try to get a shell inside my container. And when I run that, I should see something interesting on my terminal on the left. which is my canary, which tells me that someone has tried to run user bin docker runcie with the parameter -- root and another parameter var run docker runtime blah 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 blah. So now I've hijacked the runtime and basically have command execution on the underlying host, which is pretty fun sometimes. So, a bit of a conclusion about BOtB. So I've tried really hard to make it useful for pen testers and for engineers. So you can use it to get shells, get those bug bounty payouts, make it rain. Or if you want to verify exploitability, you don't necessarily want to get a shell and prove that you're a lead hacksaw, but you just want to know, okay, my environment is pwnable. You can do that. Try to make it as easy as it can be to use an SDLC environment, so with the CI/CD flags. And you want to get feedback in your environment, whether it's immediate or not. So BOtB caters for payloads that might tell you a week later when your backups run on your containers or on your orchestrated environment, and then you realize, oh, when we run backups, we're actually vulnerable to this. So having webhooks is pretty useful for that. And yeah, there's a lot more features that I haven't included in here just due to time. I've also tried with the documentation to make it as easy as it is. There's examples to run it in other cloud environments. There's a whole bunch of other examples for other stuff. Like I had a great suggestion the other day where someone said, yeah, we're running it, but because our environment has certain sockets, the builds are failing because BOtB is saying, well, they're sockets. So they said, well, can you have ignore the CI/CD flag and just alert, but just still keep the return code as 0, which kind of makes sense. So yeah, there's a lot of work going into it. So yeah, that's where you can get BOtB. It's all open source. It gets pretty interesting when you can see what new vulnerabilities you can exploit in it. And yeah, resources, like I said, this wouldn't be possible with a whole bunch of great work that other people have made. There's a more exhaustive list on the GitHub repo. But yeah, if there's time, if I can see if there is more time, we'll have questions. If not, thank you for your attention and enjoy the rest of DevSecCon. Cool. Is it time for questions, or is it my time to?
Yeah, we can do some questions. Any questions? Yes.
Hi. Very interesting talk. So you were talking about delayed attacks, and also in combination with that, not running them in production, or maybe even not running BOtB in production. Can you tell us a little bit about how you actually have that set up so that you do receive webhooks from something that's actively used? Is it like a staging environment, or?
So I am struggling to hear you. Can you just repeat the last bit a little bit louder? Sorry.
Sure. Yeah. So can you tell us a little bit about, or me, a little bit about how you're running BOtB, particularly with the delayed attacks, with the webhooks, if you're not running it in production, like how are those actually used?
Okay, great. So yeah, I'm sure everyone heard the question. No need for me to repeat it. So yeah, I'm actually using different environments on the same platform that run different tests. So I do have a production test suite that does actively run. So I have one application that is running very aggressive binary hijacks that have one specific webhook endpoint that I'm constantly monitoring. So I've just for that vulnerability that I'm testing on the platform, and then I duplicate that for other vulnerabilities across staging and production to verify what's basically going on. So in our case, we're quite lucky. The environment's quite easy to spin up stuff. So yeah, I'm happy to go through more details if I didn't quite answer your question, but segmented environments on the same platform, and that's how we're testing it, and just having things constantly trigger. Cool. At least one question. So.
Any other questions? Sorry, hard to see with the light.
Hey, essentially, like, I think this has the potential to actually create a roadmap to actually fix all these vulnerabilities in the next, like, 6 months, especially if you want to put it, like, in a in an environment that is not actually being tested for this. So like, how do you prioritize the work? Like, is there any like particular vulnerability you will be focusing, like provided that like if there hasn't been like this kind of testing like before? Like, do you think it's possible to prioritize, or you just have to go to fix them all?
Good question. I'm probably the worst person to ask about prioritizing. It's probably what I've been distracted the most by that will get my attention. I don't actually have a working recipe to actually implement that. I struggle with prioritization. That's mostly like what needs immediate attention now, and that generally follows what I go ahead and I implement. So I hope that partially answers your question.
Any other questions? Final questions? No hands? Cool. Thank you very much, Chris.
Cool. Cheers. Thank you, everyone.
And couple of announcements before we go to lunch. We